Hey guys, how's it going? Welcome to this new tutorial on dynamic charts with Excel. Just a prerequisite for this kind of tutorial, you'll basically need Excel that's higher than 2016 for the stuff that I'm going to teach you to work out. That's just an important point. So this is first a preview of what I expect to teach you guys at the end of this video. Assume you have a number of tests. You've run a number of tests. As you can see on this little box here, there's a number of tests here. And you've measured parameters of that test one by one for each second or for each minute. You've measured parameters. There are different kinds of parameters. You can measure temperature, pressure, whatever it may be. You're measuring different parameters and you're recording them. So now you want to access each parameter for each test at any instant of time. So let's say I want to look at test number 1. I click on what's called a splicer. It's just a fancy word for a filter, which is represented visually, a visual filter in sorts. You click on test number 1 and you click on the parameter that you've measured and you want to have a look at. You click on compressor top. So there is a variation that you can see. You want to see the same variation in another test. Instead of plotting a whole different chart for this particular parameter, you can just click on the splicer, test number 3, and you get the same variation for another test. Let's say you want to compare tests. So you just hold 3 and 1 together with the control button. You have both the results side by side instantaneously. So this is what we're going to learn. It's invaluable if you're analyzing data over a number of trials, and it helps in analyzing the designs of experiments that you've carried out. So obviously we'll need a data set to analyze. So I've made an example data sheet here where there are a number of parameters, and all of those parameters have been measured over time steps, which I have referred to as scan number. This represents 1 minute. It could represent 1 second, 1 hour, whatever your measurement time step is. So you're measuring time steps in that way, and at each second, in my case, in each second, the parameter is measured, and this is done over about 30 parameters for a certain span of time. And at that end of it, at the end of that particular test, I have pasted test number 2 data here. Yeah, so the test number 1 ends here. That's about 896 steps. And after that, the next trial is test number 2, where I tested the same unit, maybe with or without some variations based on my design of experiments. And then I ran the same test once more, and again measured how long it would take for the unit to finish its test. First step involved is to import our data into Power Query, which is a tool in Excel used to transform our data. So click the first cell, Control Shift right to select everything on the right, Control Shift down to select everything on the bottom, and now you go to Data from Table. This gives you an idea of what Excel thinks your data should be. It is erroneous many of the times, but in this case it's taking the correct data set. I'll just hit OK. So there's some formatting change to the table that's happened automatically. You can make changes to that at any time. So we enter in this new window where the same data is now represented in the same form, but for the table that we're going to analyze, there is a change in the data set that is required. As you can see, and you closely observe, the scan number, the test name, and the different parameters are represented in columns here. The scan number and the test code as is, but instead of the parameters being represented column wise, one by one, up to 30 parameters, we're just going to have one parameter representing each row. So I'll just show that to you to make things more concrete. I'll select the entire parameter column, scroll all the way to the right, hold shift, select the entire column again. You have the entire data set selected except for your first 2 columns. Hit the transform, unpivot, Now just closely observe what's happened. We used to have parameters represented row-wise, right? Parameter 1, 2, 3, 4, up to 30 on each row. What's happened now is those parameters are now pushed downwards, and for each of the scan number and the test 1, the parameter is just brought down and then re-represented for the entire data set all the way up to test number 2. So why this is done is to represent the pivot charts more easily. This format makes it easier for the system to play around with the data. So after doing this, all you need to do is go to File, Close and Load. So we got a table that's loaded here. Now we'll need to create a pivot chart out of this new transform data. So the entire Power Query exercise was to transform the data, and now since we've got the transform data, well, all we need to do is create a pivot chart or a pivot table out of this. Insert, go to pivot chart. So it automatically selects. Just make sure that the selection is as per what you need. We'll create this in a new worksheet. Hit OK. So now comes the pivot chart fields table, where you'll need to build the pivot chart pivot table for yourself. So first here, this represents the axis or the x-axis. We'll need time steps on the x-axis in our case. So we're going to measure, hold the scan number and drag it all the way down to the axis. So just pay close attention to how the actions on this right side of our panel are going to affect the tables here. And as you can see, each row is now represented by our scan number. What we'll do next is bring the attributes in. And what is the attribute? Attribute is your parameter, just the headings of the parameter. So all the parameters are now represented on the columns. Now you bring the value in. Value is just whatever parameter is there, the value associated with that parameter is what is represented here. So there is some information that's come up. We'll need a line chart, so we'll change the chart type to a line chart. What we'll do is add a visual filter. It's called a splicer, and for that you just click on the chart that you have ready, then go to pivot chart analyze and then insert slice, and then gives you an option of what slicer you want to have. Obviously we need the test code, and obviously we need the parameter that we want to measure or you want to study. So we click on those two, you get slicers of those two. So basically what a splicer does is when you click on it, it applies a filter to this entire data sheet. Let's observe how this works. Let's say I hit on parameter 1, right? Only parameter 1 is now plotted. So if you click on this, all parameters are still existing in the data sheet. It's like a filter, so when you click on that, it automatically checks this and unchecks all others. We now have the pivot chart plotted based on the pivot table that's in the background, and that table is dependent on the slicers that we just created a second ago. So you'll notice, first off, if you are closely in tune with the data, you'll notice there aren't any values of 4709 in your data set. Well, it isn't existing in mine. So there seems to be something different happening to the table compared to your actual data. So we'll need to dissect what exactly that is. So let's click on one of the parameters. So here you see a value that's hovering in the 150 range. Let me select just test 1. And this is a value that's hovering between the 76 and 74.5 range. Looking at my own data, this looks like the exact values to me for test 1. And I click test 2 separately. These look like exact values for test 2 as well. But when I combine the two, by holding control and clicking both of these slices together, there is an addition of those two, and those two are plotted on the pivot chart. So that's not exactly what we want, because when we select any parameter, each parameter, for example in this case parameter 10 for test 1 and for test 2, are added together and placed into the table, which is then plotted into the chart. So that's not good for us. We need them to be plotted separately in order to analyze data more clearly. The same would be happening if you hold control and click on any other parameter. So here there's two lines, which means that for parameter 10 of test 1 and 2 are added together and plotted as the blue, and parameter 13 of test 1 and 2 are added together and plotted as the orange line. To sort this issue out, you need to click on the pivot table that you've created, right click it, go to the show field list, and there's the table that opens up. You'll need to drag the test code which was previously defined into the columns tab, but while doing so, pay close attention to what's happening on the changes that are happening on the pivot table. As I drop it, there is a change, and this change is basically the fact that in the first trials, when we had parameter 1 for test 1 and test 2 were added and then placed into the table, but now there are two separate entities created for test 1 and another entity for test 2. So parameter 1 for test 1 is plotted on one side of the table, parameter 1 for test 2 is plotted on the second part of the table, and these two are plotted separately in the chart for corresponding time steps. So now when I click on the different parameters, you'll see the variation correctly plotted. You can cross-check with your data if this is in fact accurately represented. Holding control button and selecting another parameter helps you analyze both of them together